Don't get out of my way. Um, so this is a little bit of an update on the Core One fourth project on FPGAs. I found his talk very interesting. When when you try to program on somebody else's CPU design, it's their design. You can't change it. You can't change the opcodes. He talked about the data, on the one particular register is like 12 bits and all this kind of stuff. So the whole point of our um, Core One project is you design your own architecture, your own system, and you don't have to have those kind of limitations. So that's what the Core One project is about. So I'm making some changes to the board that I'm working on right now. Lattice, all these different companies are just a pain in the neck with their tools. And I'm switching to ePhoenix. Their tools are absolutely free. They don't have all this license problems. You can actually send them an email and get the tool for free. They give you more bang for the buck. Their FPGAs were designed after Xilinx and all these other companies. They kind of, if you read their technology, they've come up with kind of a better way to connect the fabric together than the other companies. I can't tell you, how that impacts performance at this point in time, but being an FPGA, it's not going to be a big deal. But it's pretty interesting. They're a Silicon Valley company, but their fab is in China. So you can kind of thank our current political people for increasing the pricing on their chips. So I'm using the Trion T120 256 IO pins. It's a 484 BGA. It has enough memory inside where we can get 173K of 32-bit wide main memory. And it also is 2 nanoseconds. You remember I was talking about, I bought, I designed in that cache chip, and, the data sheet said it was 4 nanoseconds. And then one of you guys said, no, it ain't, it's 10. By the time you write the driver for it and everything else. So what I did was I deleted that. I deleted the external memory and took the money from that, because it's like a $12 chip, and put it into the FPGA. So now we're using strictly internal SRAM. Now, what's great about that is for massive parallel processing, you can distribute that amongst lots of different processors or processes and have dedicated RAM for that. And it's running at the speed of the fabric. There's no delay in accessing the RAM. So it's like, what's the lowest level cache? Is it 0 or 1? The CPU cache, in most of these CPUs. So anyway, it's like running level 0, the very fastest cache. Your entire program runs in the fastest cache. Yeah, so here's kind of a pictorial. This is the way the board was kind of laid out. And I deleted the SRAM and I replaced it with a much larger FPGA. It has 112 KLETs. And currently our fourth computer that includes the incremental compiler and the outer interpreter and is true 32 bits is 4,700 LETs with using their tools. So just as a reminder for those people that aren't familiar with the Core One project, Core One stands for CISC over RISC engine. RISC being the fourth processor, and CISC is you can create your own opcodes, very complex opcodes using our system. So fourth is actually built on a Core One core. It sits on top. It actually sits. It's actually a coprocessor. The Core One processor and the outer interpreter compiler are actually two separate machines, and they have to talk to each other, but they run in parallel. So when you download code into the outer interpreter compiler, it's not interfering with the execution of a Core One processor. It's a full 32-bit data bus. Like I said, we have 173K of 32-bit SRAM. That's 2 nanosecond access time now. I have flash, and I got an SD card and touch display. So one of the things I want to do with this project, and I created quite a stir over for 2020, got some people very upset. So I was talking about Forth 2.0. Now, you remember last Fourth Day, Chuck Moore said something that really, got to me. He says, well, after 60 years, no one's ever come up with a Forth 2.0. And I thought, why is that? Forth is so extensible, and it's a meta language. You can create your own language. Why hasn't Forth progressed, to be a modern language that is basically looks like English? Why do you have to do all the stack manipulation and stuff? We're talking, a higher level. I'm not talking about a $2, Pico board or whatever. I'm talking about, kind of bigger applications of processing, like artificial intelligence, robotics, stuff like that. So one of the things we can do pretty quickly is the top, the add mult, it says wrote, and I intentionally didn't optimize the positioning on this of the numbers that when they type in, because I'm making a point. So you have to do wrote plus star, and then store the result, right? That's our syntax with Forth today. And it's pretty easy to go to the second one, which is still RPN, add mult, and we create an immediate word called local. And local, it should be XYZ, not XXX. Sorry about that. That's typo. But anyway, local would be a smart word and says, I don't see X in the dictionary. It would search for it, and it would just, create that in the dictionary and create a memory location so that, the rest of the your code inside the colon definition can search the dictionary and actually see X, Y, and Z in there. And then, so that'd be pretty straightforward to do. We're going to do that as a first step. And then it's RPN. Now, my thinking on Forth 2.0, and I'd love to hear your opinions on it. So what if at the bottom here says Forth 2.0 version? So one of the things is we will always support basic Forth. We'll always have the stack, swap, drop, all that stuff. So I can't use variable and I can't use constant because those are Forth reserved words. So instead, I was thinking of using Pascal like var and const. And I'd like to get to the point where you give a variable when you create it a type, so you can have structures and things like that. So, if you said int var, or you said, like C syntax, int 8 var, or you could put char var or something like that. It would create the proper size memory, storage unit. And then add mult is infix notation. Dimitri and I have been talking about the last line there, result equals, and we know how to do it. Now, if we got our syntax at this high level, which is, the way that people think a modern language, would be, that's actually more readable than I put the C version over here, right? So C is not bad, but if you don't include standard io.h, you don't know C, and you don't know you have to include all these libraries to make stuff work, that's a complication. And so it takes a while to learn C, right? So this on the 4.2.0 version is basically speaking English. And that's where I want to get to, is I want to be able to talk to my computer like on Star Trek. So the other thing is, I really like struct in C. I mean, it's very useful. So what if we had a struct in 4.2.0? And so here's one, struct is a defining word. And then field is an immediate word. So struct basically is like, colon, right? It starts a colon definition. And then field, and we would parse out the comma there. So you can put different types. You can have pointers. And so then that should be a semicolon right there. Another typo I was working on today. So, wouldn't it be nice to, structs are very nice to have. And then you pass them around using a pointer. So, this is, if anyone's looked at the Core 1 code, Dimitri, to get it working, you can either have a token, which is, an execution token in the state machine of the Core 1 processor, or you can define something inside the dictionary and one is fetching and executing, the other one just executing. So we have to be able to differentiate between whether it's in the dictionary or it's an opcode. So, like I said, Dimitri just put a minus sign in the front just to, get it to work. So, think like, I really like some concepts in Colorforth where they're using upper level bits to do things. So you'll notice right here, at the very end, you got data width. So, our data width of our system is set to 32 bits wide. You can make it any size you want. You can make it 16, 32, 53. It doesn't matter. You resynthesize, and then you have a new machine of that data width. So you can kind of optimize the fabric that it takes for your application. So what I was thinking is to have the upper level bits. So is token means that it's it's an opcode in the processor, and it gets executed, directly. If it's set to 0, then it'd be a CFA. If logic is data is set to 1, then it's going to be data in the cell. And then we also have the immediate flag. And then what I was thinking of is pointer. So the data field would be a pointer. So I think Bob would like that. So you could have lists of lists kind of thing. And remember, this data structure is your data bus, right? You're basically making these operations intelligent. where, at the lowest level of the machine, it knows whether the data, the payload data, what it is. Is it data? Is it a pointer? Is it a token? Is it a CFA? And this synthesizes just fine. It adds about 20% more to the amount of LUTs used, but it's still pretty reasonable. It's like 4,700 LUTs now with this. We don't have this fully implemented. So, I think I would like to kind of open it up for conversation at this point. What do you guys think of 4.2.0? Do you have ideas for it? Do you have suggestions? Now's the time to tell us, because we're going down this path.
There's another way to do it.
Okay.
And I don't know how you'd implement this, but think of like device drivers, right? In Unix or something, right? You have a read and a write, and you kind of know, you just know the operations, right? Read, write, and open and close and this kind of stuff. And, if you just know the data type being your device, whether it's USB or a disk or something, and you have this kind of abstraction, and you know what data type it is by the kind of device it is, and you can do this kind of abstraction. And you could probably do this like at the VHDL level instead of like the von Neumann level that we're thinking about. And this could give us like some advantages and abstraction and data types and
exactly. That's where we're heading with this. Yes.
Yeah, but we probably don't want to do it like in a von Neumann way, which has all the like, capabilities that you can only do one step at a time. Whereas, if you do this abstraction, then you can do like, you can do from low level to high level. And it doesn't matter whether your document's a spreadsheet or a Word or whatever it is, or like you just have these abstractions then, and then you just know what to do. And since all the operations are all the same, right? You're either adding or subtracting, or it's like kind of doing object-oriented without all the overhead, right? Because you just know what the operations you want to do on each data type. The operation may change if you do an integer, it's different, and if you do. So it may pay off to have like a bigger, just infinite data types. So you could like actually just figure out what kind of data types you want and what kind of operations you want to do, and not have all this overhead of but we'd have to think about like how to do this. Maybe away from von Neumann and then what kind of operations you want to do and what operations make sense, but get away from the object oriented and do this more like a device driver on Unix thing, where you just kind of just plug in the operations you need. So you don't have all that overhead. Smalltalk did it, but Smalltalk did it in an object-oriented way. We don't need to once you compile it, we don't need to do it that way.
As a matter of fact, you can add your own fields to this very easily. So one of the fields I was thinking of is type, and make it like 8 bits. 8 bits wide, and now, like you said, it could be, it could tell the inner interpreter, inner processor, how to work on the data.
Yeah, you probably want to do a type ID and an object ID and this kind of stuff, because then you can kind of just like move stuff around just by object ID and by type, and if you make the type ID infinite, there's no reason not to make it infinite. But because every imagine if every word was like its own type kind of thing, that would be great, or kind of type. And there's no reason not to, as you say, when we're away from the CPU, there's no reason not to just have like a type for whatever you need. You need a type for some kind of number, just like in Smalltalk, just no longer object oriented anymore. You need a number type, you need a string type, you need a spreadsheet type, an outline type, whatever you need. And then these things become recursive, right? Because the data types eventually become kind of like, you build one thing out of another, an outline is built out of some other objects inside, a spreadsheet has some other, and it kind of becomes recursive, the types you need. I don't know if that makes sense. And the operators are always the same, right? It's always, plus, and then you imagine pushing one of these types on a stack, right? Because now you can just push the object ID or whatever. You can push the object ID and you can push a type information and it's like, okay, do something with it, add something to it. Now you don't need to even like figure out, are you adding two integers? Are you adding you don't care, right? Because you already got the type ID.
Exactly.
So,
Yeah,
right, then
you're
it's just a
talking
question.
where I want to go.
Yeah, it's just a question of figuring out how to structure it.
Yeah,
So one of the other features of FPGAs is you can create, it's register rich. I mean, you can create thousands of registers. So you could have a type register, and instead of using the data stack, just create a type register, and you just assume one of your rules is, the type register is only valid, say, within a colon definition or something like that. So, you're not using the last operations type. Or maybe in a colon definition, what you do is at semicolon, you clear the type to 0. And then you could test for 0 and then, say, okay, yeah, there's no type. And then, you rule is you have to force the type, in your colon definition, to tell the machine, how to work on it. As an example would be, we could have an array type, we can have a string type, we could have matrix type, different data structures.
But you don't need to be that specific, right? Because you can probably build one type out of another type and then go high level. But also, I mean, it depends, right? Because you want to have an object ID, and then through the object ID, it queries like what the type is. It depends how you structure it. Like you could just have an object ID, like an FID, which is basically just a word. It doesn't matter what it is, right? It's just in order to locate it in the dictionary. Then say, oh, I've got this kind of type of thing. Right, is that enough? And then you just query the object. What type are you on? And kind of like a device driver.
There's a direction of there's a project called Cherry. I'll spell it in the chat that they've worked on the idea of having sort of a richer pointer type where you encode typically things like the range, if you've got access to a range of memory, and that the goal is there's this whole domain of stuff called capabilities, where the idea is that you want to be able to have the low-level system enforce high-level properties that you want to have. So like memory safety, but also potentially security. Sort of if you hand somebody a token that gives them access to something, you want to have hardware enforcement of that. And they have I think they've even built like an extension to RISC-V to implement it. So I see some similarity there. I'll make a pitch. One other similarity I'm seeing here, there is a structures vocabulary in ESP32 that I put in there to be able to interact with C, because it call it for the Windows and Linux versions. It needs to interact with C. You need structures, and so it's able to produce C compatible.
To see that code.
Yeah. So
if you go with the Unix model, like with the IO, read, write, and whatever, copy, move, there's like so few instructions that you can basically do everything with, and if you narrow it down to select and move and copy, you can almost do everything you want with just like a few operators. And then, the data type may act differently, but you may just get away with like, half a dozen operators and everything, and that may be enough to do everything. Manage a document, you got select, you got cut, you got copy, you got paste, it's got, and it's really only half a dozen operators to move stuff around, just do stuff with, and so these objects don't need to know a lot of operators, maybe some more than others, right? Maybe numbers need to know how to add themselves, but in general, you can probably just minimize, in the same way that Unix is like open, close, read, write, and that's good enough to do everything, and so that's, that's something
Great
to think
ideas.
about. So you don't need to make a load of data types, like a ton of them. I mean, eventually you have higher level data types, but you can just start with, okay, I just need this data type that I need to move and make instances of, right? Because I need to make a new instance of my object. If I got a spreadsheet, I need to make a new instance of my number and my cell or whatever it is. But you might not need a lot of operators.
I'm kind of creating a bunch of this discussion into my update on Cozy. because again, it's this general array language. And so all, these structures are just an instance or whatever. Oh, I'll go through that a little more if yeah.
But I mean, arrays and outlines and all this kind of stuff, it's just like, you just make one object out of another bunch of objects, and one just happens to be an array and the other one happens to be an outline, but in reality, they're almost very similar.
Actually, I'm talking about arrays in the sense of APL or K.
Yeah.
No. Oh, that's what so we have a common understanding of.
Yeah. Well, you can start going in parallel, right? Then you can start going in parallel, and that's a whole other discussion on in a spreadsheet. Yeah, in a spreadsheet. Eventually, you might want to go in parallel, and you're doing a search across a document or a spreadsheet, or now you might want to go in parallel.
Yes, you're hitting a level that is, instead of specifying a loop, you're specifying the set over which you want to have something execute.
Well, yeah, I mean, but imagine you just have all these object IDs of all these things, and you just want to do something with all those object IDs, right? Which happen to be documents or
no implication of sequentiality, except you have some words to go and handle. I mean, a cross essentially is one of the most fundamental of the APL level words. Well, anyway, again, it's a vocabulary of about half a dozen words that essentially go and factor the length into, factor loops into words, and very structured, and by doing that, you've made it parallel. The notation is parallel.
Yeah, so in other words, you just give it an array of object IDs probably, and just say add all these up, or do something, or search them all, or do something with them, or find it.
Yeah, you pass a point the object, and I'll hit that if we go. And I mean, I'm already anyway. Let me shut up and
it just seems like a good idea just to have a type discriminator, either an object or a type. And I don't know if you'd push the object with a type or just push the object ID and then.
Yeah. Let me. I mean, I've got this. So I mean, it's just is whenever, we switch from.
We can't do that. We can't do this on a CPU, but since we're defining our own hardware, then it's like no reason just not to have a type, an object type, object ID and an object type.
Yeah, that's what I'm looking for. Those kind of ideas.
So I had a little experimental language I was working on called Actor4th, and the main purpose of it was to make it very easy to create DSLs and make them type safe. So I did have something similar to what you're talking about with your structure, and actually the intent was like someday put it onto a FPGA because it's got a lot of overhead doing it on a regular CPU. But you had a type ID with with your cell, but every type had its own dictionary, and so basically whatever is the top of the stack type, that was the context of what you were executing, and so that would have priority. That would have your priority vocabulary, and then if it didn't find it in there, then it would go to the primitives, right? And then the other thing is every word as defined, the stack picture was actually the type requirements for the inputs and outputs that was checked by the compiler. So it was a strictly typed language. So you didn't just deal with generic cells. You were always expressing. You could express this. You could express the types. You did have an any type if you wanted to match against anything, and then you could also not just say the type, but also a value. And
any type is 0.
Yeah. So you could actually implement closures in it. Unfortunately, it's been like over 2 years since I've had a chance to work on it anymore. But it was pretty cool because with 3 different types, I only needed 3 types to create an entire DSL with it. It worked really well for that. You did have a little bit of weird quirks because you're a stack-based language, and you could have some leftover stuff from some operation that would cause your overloading to match. And I didn't resolve that yet, but it was neat, and it addressed the other aspect of it. Was like, Forth is not a scalable language in terms of the number of programmers that can be on the project. Is one of the things that I've always found as a challenge. And so if you have strict typing, it makes your structures more formal, more easy for people to understand just by looking at their declaration without having to look at the implementation, what the activity is supposed to do. And it makes it easier for people to collaborate on it. So that was one of the goals as well, which I think a fourth 2.0 is going to have to address.
Or you could go the small talk way, where there almost isn't a type. I mean, there is a type number and a type, but there almost isn't a type either. So that's the other extreme.
Yeah, but the problem with the small talk method is everything is a runtime lookup. Whereas with the strict typing, the way that I did it, even with the type of stack, there was most of the time, unless you were doing something that had to be polymorphic, most of the time you could tell at compile time what would be resolved. So you could have very efficient code. And but
you might be able to resolve this by knowing what the type is, like a device driver, and then you don't care because you just resolve this at compile time or whatever time. You don't care, right? You just load the device driver and it does the appropriate stuff, and you don't care because it just knows how to do the operations. You don't care what the device is; it just does it. So it doesn't matter at that point. It just knows how to respond to a plus and a minus and a print and a copy and a move and the basic, and that's it. And as long as it knows that, you don't care what it is.
Well, so you're either doing some fixed overhead to allow it to be dynamic, or you're doing a dynamic lookup that's a dynamic
or maybe you only do the dynamic stuff when you compile and interpret it, and once you compile to whatever, then you just already know what it is, and it's not going to change. A document's going to be a document, a spreadsheet's going to be a spreadsheet. You know what it's going to be. It's not going to change itself. Hopefully not.
You mean to build the app into the FPGA?
Right, exactly, yeah. And then the spreadsheet's going to be a spreadsheet, and the outline's going to be, and hopefully it's not going to change. You could, in theory, change data types, and a spreadsheet could become an outline, and an outline could become a spreadsheet, but you're not normally going to do that. So
right.
normally,
you're describing the app as an entire macro, and then the FPGA is an instance of the app, which is a neat idea, right? So you're really reprogramming the FPGA every time you have a new app. Whereas, my model was still a classic language.
Yeah, but then it's always the same stuff, right? Because the app, after a while, you build stuff after, on top of other stuff. So then you're building a document out of different document types, and you're building different things out of different things, and then eventually it's just all the same stuff, right? Then, you only need a certain number of things to build the whole thing, right? To build a word processor or whatever words or paragraphs. I mean, eventually you're just dealing with the same units of stuff. Eventually you run out of...
What you find out when you start having strict type systems is you start building a lot of types.
Yeah, but maybe you don't need to,
right? Type because it allows you to structurally set up things that can be enforced so that you can prove the correctness of your code.
Well, sometimes it's nice to have types, right? Sometimes it's nice to have.
I love it. Yeah,
but maybe you can build that in, right? So maybe you can do still regular number. If you think of the metric system, you can have kilograms and millimeters, and you can convert between weight and you can convert between all the different units. So at that point, you want to have types, but you can even build that on top.
I've got one of the most fundamental aspects of Cozy that actually got understood by these Lambda conference, whoever wrote the description of that. Let me share my screen, and that's okay. Now it's letting me share, because this is just getting as I move share. Yeah. One of the things that I'll get down to, what's being talked about is, man, my cursor is just invisible.
So why don't we ask Don to wrap up, and Bob can do his talk, since it seems like doing his talk.
Except there's a weird.
That was the main part of my my talk anyway. The other stuff is kind of you've seen before for new people. But
thank you very much, Don.